Hi everyone, this video is an exercise 12K question 6. So we have a rectangular garden which is fenced on three sides and the house forms the fourth side of the rectangle. So we have a garden which is like this, and the important thing here is that this is the fourth side, which is basically the house, but the other three sides are fences. So in part A, it says that given that the total length of the fence is 80 meters, which means the sum of these three sides. Um, so show that the area A of the garden is given by this formula, where y is the distance from the house to the end of the garden. So it's important to note that y is the distance from the house to the end of the garden, which basically means from here to here. So this is y, and here is also equal to that. But we don't know the value of this distance or this side, which can be, let's say it's x. So, and also we know that the total length of the fence, which means the sum of um, y, the two y's and x, is equal to 80. And this means 2y plus x is equal to 80. So we have this equation, and also they have given us that the area of the garden is given by this formula. But before using the formula, let's use the regular formula of area of a rectangle, and the formula is x times y, because that's just length times width. So in this case, we have the value of x, because we can rearrange this and make x a subject, and this becomes 80 minus 2y, and we can substitute this into x, so we have the formula in terms of y, because the given formula is also in terms of y. So this substituted into the formula is going to give us y times 80 minus 2y, and that's exactly the form that they asked. So this is basically the area of the garden. And now in part B, which is the more interesting part, it says, given that the area is a maximum for this length of fence, find the dimensions of the enclosed garden and the area which is enclosed. So when it says the area is a maximum for this length, that's basically about optimization, which basically means if you differentiate the equation of the area and then find its maximum, then you can find the maximum area. So that's the idea here. So in this case, um, remember that the formula of the area is equal to a is equal to y bracket 80 minus 2y, and we can rewrite this as 80y minus 2y squared. Now let's find the derivative. So derivative is equal to 80 minus 4y, and remember that the area is maximized. So we need to solve this maximization problem, which is basically dA by dy is equal to 0. So 80 minus 4y is equal to 0, and that gives us 20. So this 20 is the length of this part of the rectangle, and this will help us to find a maximum area, because this is again the maximum point in this case. So all we need to do at this point is just finding the area, which means substituting y is equal to 20 into the formula of the area, and by doing so we can find the area. So area is equal to y, which is 20, times 80 minus 2i of y, which is 40. So, and then inside the bracket we get 40. 40 times 20 is 800, and the unit here is meters, so it's 800 meters squared. That's the area of the garden. Okay, that's it for this video, and thank you for watching.